You know what? Okay, I think now it should be working, hopefully. You know what? All right, there we go. Okay, let me I think now it should make sure I don't get a feedback loop here. Okay, yeah. Sorry about that. All right. Mute that guy. All right, awesome. Got audio working. Sorry about that. Okay, yeah, let me try switching to my other microphone. Well, I don't know. I don't want to mess with it now that it's working. Anyway, yeah, thanks for your patience, guys. That was a little bit annoying, but yeah, I think I got it working now. Cool. So yeah, let me get the screen share going again, and then yeah, now we can actually do some stuff. All right. Anyway, cool. So now, does anyone know if there's a way to make this green thing go away? Anyway, that's probably fine. Anyway, yeah. So now we've got actual audio. So now we can talk about what we're actually working on today. Yeah. So basically, the idea is I've got this plugin that I'm working on, and I wanted to add some like a state variable filter module or tool to it. I've been calling these tools just because it's Chow multi-tool, but so this is going to be a state variable filter tool. And right now all we've got is a cutoff parameter and a queue parameter and some ranges for that. And then, yeah, now we've got to fill in the actual DSP and UI and everything else from there. So I'm going to start with some really simple stuff. Actually, I'm going to start with a little bit of UI just so that we can see everything that's going on. David wants to know what code editor. This is Sea Lion, and I use it with the Cobalt color theme. Yeah, Cobalt 9, I guess. I don't know, I like the blue for some reason. It doesn't bother me when I look at it for a really long time. But yeah, anyway, so first you've actually got to add the processor to the plugin. So this will be done here. Yeah, so one thing that's a little bit annoying is that I have this tuple of tools here, and I can't really initialize the tuple the way that I want to. So I have to do this funky thing here where I initialize each element of the tuple separately without using the constructor. I might go back and try to fix that in a few minutes here. Yeah, that was something I was thinking about today. But anyway, so it's kind of cool because the only thing we have to do to get this guy working is just do that there, and then it'll be easy enough to get working. So yeah, let's add a little GUI for it just so that we can see what we're doing as we go. So this will be SVF editor. Yeah, and then I'm going to want some kind of filter plotting for this guy as well. So I'll just make a class now. It's called SVF plot. Yeah, we'll fill that in later on when we're ready. But yeah, I'll just put that in the C8 file for now. Right. So yeah, we don't need to worry about the plot yet. And then for this guy at the moment, it's just going to be a only pragma once. For this guy at the moment, it's just kind of going to be a default UI. So I'll just do it the same way I've done it elsewhere. Yeah, so we can do it kind of like this. So I need to include the DSP that I'm working with. And I need to include the plugin state. And I don't need the end of the include guard there. So yeah, we'll put this in a namespace as well. GUI SVF. Yeah, and so we can do pretty much the same thing we did here. Except now it'll just be with the SVF instead of with the wave shaper. And then this will be the SVF params instead of the wave shaper params. And now let's do our implementation. So we're going to want these, and for now, well, I'll just do the same thing that I was doing here, where you just create the parameters view kind of as a member variable. And then you add it as a component. And then you just make it the whole bounds. Cool. And now we've just got to add that to the overall plugin UI. So let's do that here. Add one more thing to the big if statement. So this will be SVF, SVF processor, and SVF editor, and then of course SVF params. And that should be all we need to get going. So let me give that a try and just make sure that we're able to see our parameters on the screen. And then, yeah, then we can add a little bit of DSP and make sure that that's working. All right, so yeah, this will take a minute. Oh yeah, I got my namespaces wrong, didn't I? That's okay. We'll get that this time. Cool, yeah, so I guess back to the problem I was talking about. So I've got this types list, and then I use it to create a tuple of all the tools here. And the problem is that you can't really dynamically initialize a tuple. So I've got right now I've got these silly little initialize functions in every single one of the processors, but I don't love that. So yeah, maybe it's time to try to get something better working. So maybe I'll take a look at that today as well if I've got time. But yeah, that's probably just going to be some kind of C++ wizardry that maybe isn't always the most fun thing. So yeah, we can think about that maybe if we want to, or maybe I'll just leave it like this. This isn't the worst pattern, even if it is a little more verbose than I'd like it to be. But that's okay. stub out a little more code while it's compiling. Help if I could spell that right. And yeah, then I don't need these extra declarations here. So yeah, let's give that a try. All right. Yeah, it's taking a little while to compile. Hopefully it'll go faster after this. Oh, I see. Okay, you're just down there at the bottom. Okay, yeah. So let's pull this up in Bitwig and see where we're at. Yeah, so now we've got the SVF tool down here, and we've got our parameters, which seem to be connected to the correct parameters in the plugin. So that's nice. And then let's set up the EQ curve analyzer, since that'll help us actually see what the filters are doing once we've implemented them. So yeah, right now, as you can see, we've got no DSP, nothing's happening. And that's what we're expecting for now, but now we actually do want some DSP happening. So let's go ahead and get that going as well. So let's start with just an SVF low pass. And so this will be, call it plain LPF. And then here, what we'll do is we'll do plain LPF prepare with this process spec. Here we'll do plain LPF dot reset. And then here we'll do plain LPF process block. And then we also need to set all of our parameters. So we'll do plain LPF set cutoff frequency. And set Q value. And yeah, this should get us going just as like a simple thing to make sure that audio is in fact going through the filter that we've set up here. So yeah, the next thing that I'm thinking we're going to want to do is set up a couple of different types of filters. So I'm thinking that we'll have these kind of plain filters, and then we'll have some other more different filters, which we'll see what those are in a second. So yeah, that should be fun. Alrighty, hopefully this will compile a little faster here. Hey, Pedro. Pedro says hi. Hope you're doing well this morning. Or maybe it's not morning where you are. Hope you're doing well, whatever time of day it is. All right, we're getting somewhere now. Awesome, cool. So now we should be able to see something in the EQ curve analyzer that shows us what our filter is doing. That's a good sign. And then if we move around our cutoff frequency, we're seeing that our cutoff changes. If we move around our Q parameter, we see that our Q changes. And maybe I should put the center of this range somewhere else, because it seems like towards the bottom, you got a lot of time right around 0.5, and then only, maybe a third of the way into the slider range do you get to that. So maybe I'll put the center somewhere else. And that's not a bad idea. Yeah, let's put the center at like, I don't know, 2.5. Okay, so let's do a couple of enums here. So we'll have an enum class for SVF type. And so we'll have plain. And then we'll have ARP, that'll be fun. And then I was going to do a version of what I call the Warner filter, but we'll get to that in a minute. And then we'll do, so this will be plain types. So for the plain filter, let's see what types we can work with. Come on, there we go. All right. Yeah, so we've got all these basic things: low pass, high pass, band pass. I guess I'll do all pass too. Maybe some of them will have some cool ideas of what to do with that. We've got notch, we've got bell, and then we've got multi-mode. Multi-mode, I feel like I'm gonna have to treat a little differently, so I'll leave that one out for now. So we'll do low pass, high pass, band pass, all pass. Well, even bell, low shelf, and high shelf, I might have to do a little differently. But anyway, we'll get there. So low pass, high pass, band pass, all pass, notch, bell, low shelf, and high shelf. And then, you know what? I'll put multi in there as well. And we'll deal with that when we're ready. So now let's add a couple more parameters here. Choice parameter for SVF type. So this will be, I'll just call it type. And so we can do something like this. So this will be SVF type. And then I'm missing a couple of arguments. Let's find out what those could be. A default choice and then some character mappings, but I don't think I need a character mapping on this one. Default choice should be, I'll make it the plain. Yeah, the plain type. Okay, and then how do I want to handle this on this end? I'm thinking of doing a tuple. So we'll have SPF low pass as the first thing in the tuple. And then we'll just have a bunch more things. So we'll have high pass, have band pass. Let me make sure I'm getting the same order. High pass, band pass, all pass. Notch. Bell, and then we've got high shelf. We've got low shelf, and then we've got multi-mode. And these are our plain filters. Yeah, so then what I'm going to do from there is, instead of calling prepare like this, I'll do tuple helpers, for each in tuple, and we'll do use our spec there. So we'll do filter. And so we'll do filter dot prepare spec, and then I think I also need a second argument for that, and then I need to pass the plain filters into it. Yeah, that's about right. And then we can do this for reset as well. Cool. And then here, we need to handle things a little bit differently. So we're going to have other tuples. So like, we're going to have another tuple for the ARP filters and another tuple for the other ones as well. So let me think about how this should be done here. So process filter type. And this is going to be a tuple of filters. And then what we're going to do is we're going to have an auto type for the filter. We'll call it subtype. That's what the search synthesizer folks use, and that seems to be fine. So now what I'll do is I'll do ChowDSP tuple helpers visit at. So I want to visit my filters tuple at the filter subtype. And then here I want to actually process a buffer of audio and maybe do some other stuff too, depending on what we want to do. So this should be the tuple, the index, and then the function. And the function is going to be called with the signature. Oh, with just the element. Okay, so I can just put my filter in here. And then here I'll do filter process block buffer. And for that to work, I also need to pass my buffer through the capture lists to get that in there. So that should work. I'm going to want to do a little casting here to make this a size T instead of whatever. It's going to be an enum type, but we're going to want it to be a size T for this function call here. All right, and then I'll comment that out for now so I don't forget it. So we'll do if brands type equals SPF type. Yes, will be plain. Then we'll do process filter type filters tuple. Well, that wasn't the name of it, was it? It was plain filters. And we'll just do index 0 for now, which is not really what we want, but that's okay. Let's see. Yeah, okay, we'll just do get, and that'll be fine. Okay, yeah, so that's more or less what we want, but now we need to get this filter subtype. So we're going to need another enum choice parameter. this will be plain type. Maybe I want this to be plain type instead of plain types. Yeah, because this is type singular, so I'll keep it consistent like that. Okay, so plain type, and then this would be plain type, and low pass will be the default. And then before I forget, I also need to add these parameters to the plugin state. So this will be type and plain type. And I forget something here. Yes, I did. I forgot to make these pointers. There we go. And that explains why things were being a little bit strange here as well. So this should be star parameters plain type. Something's not happy with this. Call to deleted constructor. Okay, that's because I need to actually call get here, because otherwise the implicit conversion won't work. Okay, still not happy, I guess. That's fine. All right, so now we've got this. And so we're also going to need our set cutoff frequency and set Q value methods. So let's go ahead and do that. So to get params, we'll also need to capture this. Cool. So I think that should work, and that should get us all of our different filter types that are in the plain filters subtype. So let's give that a try, and hopefully that'll work for us. Okay, someone's got a question. Can we download your repo and learn on it, especially distortion plugin? Yeah, all of the repositories that are on GitHub, you can download and do mostly whatever you want with. There's a couple of rules based on the different licenses of the different repositories, but they're the reason I put them open source is so folks can learn from them. So yeah, go ahead. And yeah, hopefully make something cool that's hopefully whatever's in that repository will inspire you or help you to make something cool. That would make me happy. All right, yeah, so while this is building, I'll pull up some of the other filters that I was going to take a look at here. So I was going to do something with this ARP filter, and then I was going to do something with this Warner filter. I might do some extensions on these though. Yeah, we'll see. We'll see what I want to do there. That could be interesting. Yeah. So the art filter here. This is based on. I think I've got the. Yeah. This is the paper for it. If I can open it up here. Yeah, this is kind of an older paper, but it's really interesting if you're ever able to get a chance to read it. Yeah, it kind of shows off this this filter and sort of the musical nature of it in a really interesting way. So this is the sort of schematic or a rough schematic of the filter. And so that's kind of what we're going to be working from. And so they've got these 4 different outputs, and with the notch output, you can you have this extra sort of knob that you can fiddle with. There's also this limit mode, so I got to figure out a way to maybe work that into there somehow. Yeah, I'll think about how I want that to work. Anyway, we'll come back to that in a moment. right, so we've got our SVF. We've still got our cutoff parameter working. We've got these other filter types, but right now they won't do anything because we haven't implemented them. And then we've got these subtypes. So let's check if these work. So high pass, that seems to work. Band pass seems fine. All pass, that seems right. Let's see if we can show the phase. Yeah, it seems to work. Pretty cool. And then, yeah, these ones aren't really going to do anything yet because we don't have a gain parameter. So let's try to get a gain parameter in there, and then we can take a look at what those are doing. So let's see here. dB parameter. All right, so we can do something kind of like this again. This will be SVF gain, SVF gain. Let's see, since that's in decibels, we can probably just do a regular juice normalizable range. And we'll do minus, oh, I don't know, minus 18. Is that enough? We can make this, we can make it go further if we want. Yeah. So, yeah, one thing we're going to want to think about is, that the gain parameter is not active for every combination of filter type and subtype. So that's probably something we're going to want to show on the UI, but yeah, I don't know, I'm not too worried about that just yet. We can work that out later on. So what we're going to want to do here is have sort of an if. Well, yeah, let's do this. So let's do using filter type equals decal type, and then we'll do a decay on this. Well, actually, I'm reversing this. So decal type filter, and then we'll want to wrap that in a decay, just in case there's any other sort of modifiers on the type that we don't really care about at the moment. And so, yeah, then what we can do is we can do if the filter type, is SVF bell, then filter dot set gain decibels grams gain. And so we're going to want this for some other filter types as well. And so I'm wondering, because we could do this and then you know, or the next type and whatnot. But that's kind of annoying. Yeah, it's a lot of things. So let me check. I think what we want is like stood disjunction, if I remember right. I've done this before, but it was like kind of a while ago. The logical disjunction performing a logical OR on the sequence of traits. That's basically what we want. Yeah, so that's basically what we want, but we want it in sort of a variadic way. Let me see if I can find where I've done this before. It was like a while ago, so I'm not remembering it perfectly. Yeah, okay, so we can do is same. Yeah, is same with like a triple dot kind of thing. So let's do this. Template, type name, filter type, and then type name, we'll call this test filter type. So we want to know if filter type is one of the test filter types. So this will be bool is one of filters. I don't know. We'll find out if this works. So is one of filters equals to is same. And this would be filter type, other filter types. Oh no, this should be test filter types, right? So we kind of want that, but we want this to be variadic. Yeah, that's it. So filter type, test filter types. Yeah, I think that's fine. And then we just need this old expression, right? Sort of, we need the disjunction sort of wrapped around that. Template argument for template type parameters must be a type. Okay, what did I do wrong here? Value here. Template argument, template type parameter must be a type. So it's not happy with this being variadic. Interesting. Template parameter is declared here. Oh, okay. Interesting. Oh, I see. Okay, so I need to do the version of this that is a type, and then I can do the value at the end here. All right. I think that should work. So yeah, let's try this. If is one of filters, filter type, and then we can do our variadic other types. This we have bell, this VF, low shelf, shelf with an S, and oh, I forgot the ChowDSP, or ChowDSP SVF high shelf, right? Yeah, okay. So if we're one of these filter types, then we want to set the gain in decibels using that parameter. All right, let's double check if that works. Ooh. Yeah, these kind of funky template things, I enjoy them. I find them fun, but they almost certainly make this code harder to understand. But I don't know. I enjoy them, so maybe I'll leave it there. Anyway. Cool. Yeah. So then the other filter type I was going to work with is this. I call it the Warner filter, which I don't know if Kurt would enjoy this, but Kurt Warner wrote a paper about this filter architecture, and I really like it. So yeah, I named it after him. Or when I use it, I just call it the Warner filter. I don't know if I am responsible for naming it, but we'll pretend that I am. Anyway, so yeah, this is kind of fun. It's got a few different ways of getting the filter output, and yeah, I might change one or two things with how I'm doing the process sample method here. Where am I doing that? I think it's down here somewhere. Yeah, this was a fun one to do the derivation for, though. I got to do some pretty heavy experimenting with Mathematica, which I hadn't done before at the time, so that was pretty fun. Maybe we'll go into that if folks are curious. Anyway, let's double check that this gain parameter is working. Well, it's not, because I forgot to add, whoops. Yeah, all right. Yeah, anyway, while this is going, let's take a look at this. I don't know, maybe people will find this interesting. So this is sort of a derivation of the filter. Actually, I'll show the filter as well, since we're talking about it. Yeah, so this is from a 2020 DAFX paper that Kurt Warner wrote with Russell McClellan. Both of them were at Isotope at the time. Yeah, and so it's kind of talking about some different state variable filter architectures and kind of trying to generalize them in different ways. So they talk about the Moog ladder filter. This is the octave cat filter. And then they come up with this kind of generalized filter architecture, which I'll find here in a minute. Yeah, here it is. This is kind of the generalized filter that they're talking about. So you've kind of got these two second order state variable filter blocks, and then you've got kind of this global feedback that's feeding back over all of them. And then they kind of show how a lot of different filter types kind of fit within this architecture. Yeah, they've got some kind of cool plots that come out of it. And then, yeah, so you can kind of see here how for different filter types with different versions of the parameter, you can get these kind of interesting filters. So yeah, you've got sort of your Butterworth filters, your Chebyshev filters, and then this Moog filter. They've got the octave cat filter, both an approximate and an exact version. I forget exactly why they did that. And then this thing they call the monotonic version. But yeah, it's pretty cool. It's a pretty cool paper if you're interested in this kind of thing. Definitely recommend checking it out. And yeah, definitely check out all of Kurt's research, because it's a pretty fantastic body of work. And he's still just getting going. I'm sure he's got a lot more really cool things planned for his future papers. So yeah, but anyway, so they do a little derivation here at the end. I messed around with this derivation a little bit, but there's a couple things that I didn't love about it. And I kind of want to just go through rederiving it for myself, just because I find that kind of thing interesting. So that's where the Mathematica notebook comes in. And yeah, I can talk more about this if you guys are interested. But anyway, we'll get to that. Cool, so now we've got our gain parameter. And so if we do a, let's see, a Bell filter, and we give it some gain. There we go. All right, yeah, so now we've got sort of all of our plane state variable filters worked out. So yeah, what should we do next? Should we do the Warner filter or the ARP filter? Or should I take a break for a second and maybe grab some water? Yeah, I'll grab some water, but if anyone's got questions or anything, feel free to pop them in and I'll answer them when I get back. Okay, we've got a question on, is this repo on digital circuit modeling by Eric Tarr? I'm not sure which repo you're referring to, but Eric does have a couple of pretty cool repositories where he talks about circuit modeling. Yeah, Eric does some great work. Definitely check out his most recent thing. It's his, I think he calls it like his point-to-point modeling library or something like that. Yeah, it looks super powerful. I haven't actually tried it myself, but yeah, all of the demos that I've seen and things like that look pretty impressive. So yeah, it's a really cool bunch of work that Eric's doing. All right, so maybe maybe we should do the ARP filter next. I'm wondering. Yeah, let's do the ARP filter. So it's got the same sort of thing here with set cutoff frequency, set Q value, and whatnot. Also, I wonder if maybe we should change what we're doing with these set update or should update things, since, yeah, maybe we can handle these a little bit smarter. So basically what happens is when you call set Q value, it changes the internal Q value that the filter is using, and then it updates all the filter coefficients. But since we're changing all of these parameters at the same time, we should not update them immediately. And then here, right before we process, we can do filter dot update. What's it called? Yeah, just update. Yeah, so that should work. Oh, you know what we haven't done yet is the multi-mode. This one's a little bit tricky because it's sort of a, I don't know, we might want this parameter to be a little bit smoother than the others. So with the other parameters, the state variable filter handles parameter changes reasonably well, as long as they're not like insanely quick. I mean, we still could add a little bit of smoothing if we want to, but usually it's okay. But for the mode parameter, we're probably going to want some smoothing. I'll do it without smoothing for now, and then we can add it in later if we want. I don't think it'll be too bad. Anyway, so we've got the multi-mode type. So yeah, let's add a parameter here, which we'll call the mode parameter. And this will be a percent parameter. So this will be SVF mode, and a couple of these filter types have different modes, so we can use them whenever we want. And I'll put it at 0 for now, since that corresponds to low pass. Yeah. All right, and then we'll do over here as well. And so then we can do if const expr is one of filter type, SVF multi-mode, then we'll do filter dot set mode, and we'll do params mode. And then we'll add a to-do here, maybe smooth this parameter. Yeah, okay. Anyway, I feel okay about that, so I don't really want to build it again. We can test that out next time we do some testing. So ARP filter is a little different in that the mode is a parameter. Well, how was I doing this? Filter type, ARP filter type. Where do I actually set this? That's the question. Oh, okay. I do it when I call process sample, I guess. Yeah, where does that actually happen? ARP filter type. Okay, so Yeah. How are we going to do that? Interesting. Okay. I have an idea here, but it'll be a little bit annoying. Well, nah, it'll be fine. Yeah, it won't be that bad. All right, so next we'll do this will just be a tuple of 1, I guess. Yeah. Well, let me think about this for a sec. Let me just keep it as its own thing for now, and then I can figure out how to fit it in with everything else later. So this will be an ARP filter. All right, so we've got ARP filter, and then we'll do the same things that we've been doing before. So ARP filter, prepare. Filter, reset. And then, yeah, here I might want to handle things a little bit differently. So here we'll do if type get equals SVF type ARP. Yeah, so here we'll want to be a little bit, here we'll want to do things a little bit different. So yeah, maybe let's make a second lambda here. So set filter params. And for that one, we should only need this. We shouldn't need the buffer or anything. And then we can just copy all of this logic pretty much into there and put a filter in as the argument. And then we can just pass this in to this lambda. So we'll want to set the filter params of the filter. And then we'll want to process the block. And so the difference will be that here, oh, I should make this an else. If here, we'll just want to call that directly. So we'll do set filter params, ARP filter, and then ARP filter process block. Yeah, so this is where things are going to get a little interesting because now we need this template type argument. Yeah, so we'll work this out here. Well, first we actually need the parameter for the ARP filter subtype. So what's nice about this is that I can actually, well, actually, why didn't I just do this for this also? Yeah, well, I should have done state variable filter type for this parameter here, but I don't want crossover mode. So whatever, I'll just leave it as I have it for now. Anyway, enum choice parameter, ChowDSP ARP filter type. Oops, ARP filter type. This is ARP type. And yeah, so we can just do the same kind of thing we've been doing with the others, except that here I'll want this instead of plain type. Oh, and then we want this to be a pointer, and we want to change a couple of names. Cool, yeah. So now we've got our archetype. Let's make sure that we add it to plugin state. And then what am I doing wrong here? Set cutoff frequency. Is that not what it's called? No, that is what it's called. All right. What are we not happy about? Okay, yeah, this is a template dependent name. So we need to do it like that, I think. And now it's probably happy. Okay. Anyway, so now I'm going to try to do an enum switch, if I remember how to do this. Enum switch. No, enum case. No, what am I doing wrong here? Enum. Yeah, so this is a pretty cool library that I use a lot. It's called Magic Enum, and basically the idea is that it gives you a bunch of cool things that you can do with enums. And so what I'm trying to do here is this enum switch. So I should be able to do it like this. Yeah. So why won't it let me do that? Oh, should be is archetype get. What are we not happy with? No member named enum switch in namespace magic enum. That's odd. I thought we would have it. Maybe I need to update the magic enum dependency. I probably need to include this, don't I? Enum switch. Yeah, okay, so I hadn't included that. I don't know if I want to include that in everything, or if I just want to include it here. I think for now, I'm just going to include it here. Yeah, for now, I'll just do that. Anyway, so what's nice about this is that now I can make this a const expert a const expert art filter type. Yeah, so that's kind of neat. And then what that will let us do is just call this directly. So I can do arc filter dot process block with this argument and then buffer. So I need to capture the buffer to make that work. But yeah, that should just work. So let's see. Let's see if that does it. Yeah, I think that's about what we want there to get the art filter working. And then all I would need is some additional parameters for the extra like weird notch parameter and for the limit mode. But we can get those in a sec. Ooh, all right. What time is it? Okay, 10:30. Yeah, maybe we won't get to the Warner filter today. Maybe I'll do that next time. Okay, so we're missing a template thing here. Yeah. That should be fine. Anyway. Oh, let's just rebuild. Ooh. Cool, yeah. So kind of the next steps for this SVF guy is I'm gonna try to get the Warner filter going, and then maybe I'll add another, maybe one or two kind of funky, interesting filters. Yeah, I've got a couple other ideas for things to do with this one, with the Warner filter specifically. So I don't know, I need to think about that a little bit. But yeah, let me think about this. Maybe I kind of already know what I want here. Yeah, so there's kind of this this main filter kernel here, which is kind of doing the sort of I don't know, you could call it a transition matrix, and then at some point we're doing state update, aren't we? Yeah, try to remember this. It's been a while since I looked at this code. So yeah, where does this get called? Called in there in process sample. Calc mixing constants. Wow. And then yeah, okay, so a couple of different process sample things. Okay, yeah. So nothing too crazy. So yeah, I'm trying to remember, where do these state updates come from? Evals. Interesting. So then where does SR get updated? And also, what happens, like, where's our state stored in this filter? So apparently it's stored in this state. What's this, a vector? Yeah, vector of X and D stuff. And then, yeah, where do we actually update the state? That's what I'm trying to figure out here. Well, okay, it happens in process sample internal, and then I put it in this S variable. So where does S, what does S do? So S, okay, it goes into this SR thing here. So that is the state that's getting multiplied by the coefficients here to get these T values. And then we're doing some funky indexing. And then, yeah, so where do we actually, oh, okay, here's where we do the state update. Okay, and I did a sort of a clamping thing. And I might add another mode to this that's maybe got a bit more nonlinear stuff going on. I don't know, I haven't decided yet. Anyway. Yeah, I guess, do people want me to go more into the math of how sort of the derivation for that filter works? So I'm happy to do that if folks are interested, but if people don't really want to hear about it, then I also don't mind staying away from that side of things today. That's fine with me. Anyway, yeah, so this is our ARP filter. We've got our band pass, our high pass, and our notch. Cool. And so then we just need a couple of extra parameters for the limit mode and for kind of the weird notch parameter. So that'll be fun. Athena says, nice filters, don't know how they work, but let's watch anyway. What a weird sea lion skin. Yeah, I don't know. I used to kind of, not like externally, but kind of internally, when I would see someone using a weird like skin or a weird color theme for their code editors, I'd be like, like, what's that about? Just use like a regular skin like everyone else. And then I don't know, I can't really do like regular light themes because they bother my eyes after a little bit. And so I started using dark themes for a while. And then the dark themes would kind of like they were good at first, but then like after, you know, you're working for a long time, I would find that I was kind of squinting a lot to see the kinds of things I wanted to see. But for whatever reason, this blue theme just kind of works for me. And I don't think it looks great, but I can work with it for a long period of time and it doesn't bother me. So yeah, that's good enough for me. Oh, they say light theme is blasphemous. Well, that was the default for whatever editor I was using at the time. So I think it was Notepad++. So at the time, I didn't know how to change it. So that's what I was using. Yeah, I should say that. That light theme is blasphemous. That's a good one. All right, cool. So let's add a Boolean parameter for the arc limit mode. So this will be parameter ID. Let's get arc limit mode underscore there, and then we'll do parameter versions version parameter version it's version. What did I spell wrong? I'm missing an S. There we go. And so this would be arc mode, and we'll have it off by default, I guess. And then what's the rules for the notch parameter? Let's see. Notch parameter goes -1 to 1. So yeah, it goes between high pass notch and low pass. I wonder if we should just reuse the mode parameter for that. The problem is that it's a what do you call it? Right now it's 0 to 1 parameter. You know what? Yeah, let's just reuse it. I need to remember now how to make it bipolar. Is bipolar. Okay, yeah, so I just need to add a extra thing. So we'll make this bipolar and then we'll just rescale it later. I think that'll make more sense from the user side anyway. So whatever. So we'll do 0.5. Like that. Yeah, and like I said, maybe we'll want to smooth that later. But then the other thing we'll want to do is use that here as our extra parameter for the arc filter. Anyway, and then one more thing we want to do is set the limit mode. Where do we set limit mode here? In there somewhere. Here we go. Set limit mode. Turns on the arc filter's limit mode. So we can just do this here. There's one of filter type ChowDSP arc filter set. Oops. Set limit mode. And this will be arc limit mode. Cool. And then I need to make sure that I have all the parameters added to the plugin state here. Let's give that a try. All right, yeah, so we're not too off from where I want to be with this. So then I guess kind of the next steps are getting the Warner filter working, maybe, I don't know, one or two other filter types working. We'll see. we'll see what I want to do with that. And then of course the UI. Yeah, the UI side of things. I was going to try to do something similar to, well, actually, maybe I wasn't sharing my screen yet at that point, but I'll show you guys what I'm doing with the Pultec EQ. I'm doing the UI for that, and I'll probably do something similar with this guy. So yeah, we'll take a look at that in a sec. Whew. Okay, Dean has a question here. I'm new to the Juice framework, but have experience with C++. Apart from straight reading the documentation, do you have any learning resources you would recommend? Yeah, someone actually asked me a similar question recently, and I had a little bit of a hard time answering because there's just so many more resources around now than there were when I was starting out. So like when I was starting out, I mainly was following the Juice examples and things like that. But now there's so many other things. Definitely, I would suggest checking out. I think there was a talk at ADC like a year or two ago where they were talking about like I think it was the Juice team that was giving a talk, and they were talking about like setting up a project with Juice and getting started with it. Yeah, there's definitely also some good stuff on the Audio Programmer channel and Discord and all of that. Yeah, folks there are doing a great job with yeah, making content for people who are just getting started with Juice and people who are at kind of all levels. And yeah, I mean, the Juice documentation is great. Personally, I think that's Juice's best feature is the documentation that they have. So yeah, that's definitely not a bad thing to do also. And then I guess it also just depends on like what you're wanting to make. Like, are you wanting to make plugins or you wanting to make an app? Yeah, there's some different things you might want to look at depending on kind of what your plan is. But yeah, I mean, there's a lot more things out there nowadays than when I got started. So whatever you find, I'm sure it'll be pretty good. Yeah. And then, oh, we need a filter that unfilters the signal again. Yeah, that's a harder problem. Yeah, unfiltering a signal is difficult. Okay, so we've got kind of this is a little bit backwards from what I was expecting. Yeah, so I was expecting, well, first of all, I want this to default to 0, maybe. Well, I don't know. Yeah, maybe I'll make it default to 0. Yeah, okay. And then it's a little bit backwards on this one. So I want minus 100 to be the low pass mode and plus 100 to be the high pass mode. So I need to flip that. That's okay though. It's not too bad. Yeah, so you can get some kind of cool behavior out of this filter with the notch mode. Yeah, this is a kind of fun one. And then let me double check that the limit mode is working. Yeah, there we go. Yeah, so the limit mode is kind of cool. So basically, like right now we have a filter with some cues. So if limit mode is off, then the passband gain is 0 dB, and then our cue gets us some resonance up to some peak. And then if we turn on the limit mode, then that puts the peak right around 0 dB and lowers the passband gain by however much it needs to get us there. So yeah, that's kind of a cool way to work with your filter. Yeah, the R filter can get some neat shapes out of it. All right, so for the mode parameter, let's make it default to 0. And then when I'm using it down here, I'll do a negative version of it. And that should be about what I want. All right. Do we have the time to do the Warner filter real quick? Yeah, let's just do it. This will be fun. So let's see. For the Warner our filter. We should have a lot of the same kinds of things. Okay, so this one's got a little bit different, yeah, kind of a little bit different way of doing things here. So, yeah, I'm gonna have to think about this a little bit differently for how we're calculating the coefficients, but I don't think it'll be that bad. And then let's see, so we've got the different types, and how are we using the different types? We're using them when we call process block. Okay, so we're doing this one kind of similar to the way we're doing the ARP filter. And then in multi-mode, I guess we have this extra thing. Okay. Yeah, okay, so we can do this pretty similar. So yeah, so let's see. Let's do arc type and make a copy of this, and this will be inner type. I wonder if I should ask Kurt for his permission before naming this thing after him. Or maybe he's okay with it. Let's see. Learner filter type, and we'll do low pass 4 as the default. And then we also want a percent parameter for the damping. So let's see here. Oh, oops, wrong one. Percent. And this will be damping. And we'll have this start at 0.5 maybe. Ooh, yeah, I think that'll get us most of what we want. Someone's not happy with something. Oh, yep, I've got the wrong template argument. Cool. So type and order damping. Oh yeah, this one is float only for reasons that I'll explain later if people are curious. Although maybe I should relax that if I ever get what do you call it, AVX stuff happening with this plugin. Well, anyway, that's a different story. All right, so else, yeah. So let's see, params type, and equals SVF type. Yeah, so I'm not going to want to call set filter params because things are happening a little differently in the way we're doing this, but the enum switch is actually not too far from what I want here. So we can do that. And then, yeah, so what I want to do is this calc coefs method, which, yeah, it gets a little hairy in there, but we'll get to that. So calc coefs, so the cutoff frequency will be the same as what we've been working with. Params cutoff. The damping would just be the parameter that we just made. Damping. So the damping is expected to be in the range 0 to 1. And then the resonance is also expected to be into the range 0 to 1. So let's do something here. Resonance equals, so let's try this. Params, Q param. And then let's see, can I convert to 0 to 1? So yeah, we'll get the 0 to 1 version of this parameter. Params Q param. And then we can use that as the resonance. And I think that should work. Cool. And so then what we're going to want to do is do if type equals if it's the multi-mode type, then what we're going to want to do is call the version of this that takes an extra parameter for the mix, right? So the mix should be 0 to 1. So we want to do that the same way that we were doing this here. So let's see, let's auto mix equals that, and then this can be mix. And then let's see else. We just want to do the regular process block, so we don't need the mix parameter. I think that should do it. I think that's all we need here. Yeah, hopefully that compiles. Hopefully I didn't mess up any of the funky template stuff in here. I think it'll be okay. But yeah, so I'll probably end the stream in a little bit here since I've got a few other things to do today. It's already 11 o'clock where I'm at. But yeah, if anyone's got questions or things they're curious about, or yeah, wants to see anything else that I'm working on, just let me know. All right, let's see here. Cool, so let's try out the Warner. Yeah, here we go. Here's the Warner filter. So we've got the same cutoff parameter, same kind of thing with the Q parameter. And here we can see the damping kind of go into effect. So yeah, if we pull the damping down, we can go as far down as we want, or we can do no damping. And then we're somewhere around there. Yeah. Yeah, no damping, like right around 0, things seem to get a little wonky there. And I'm not too worried about that. Yeah, so this is a pretty fun filter. You can do some cool things with it. So yeah, I'm pretty excited to have that one in here. And then let's double check that multi-mode is working. So mode. Yeah, seems to work. All right. Yeah, and multi-mode is a little weird with this one because the damping only applies to sort of the low frequency band. So when you have it on low frequency mode, you get your damping. When you have it on when you have it on low pass mode, you get your damping. And when you have it on high pass mode, you don't get damping, but you get sort of this other weird behavior on the low pass side, right? Like this is different from you had no damping. Yeah. So that's kind of a funky one. I haven't fully wrapped my head around it yet. But you can do some cool stuff with it. So yeah, and that's the reason why I wanted it in here, is because yeah, I found it kind of useful for some of the just sort of random stuff I was doing musically, and yeah, it's kind of fun. So let me make a few notes for myself for next time. So let's see, let's do a filter visualizer for SVF, parameter smoothing for SVF. Because right now none of the parameters are being smooth, so it's going to be, yeah, it's good. It's probably going to be a little bit odd. So filter visualizer, parameter smoothing. Actually, I'll just put these all under SVF umbrella. Filter visualizer, parameter smoothing, other modes, maybe more non-linear stuff. Yeah, and then, we've got a lot more UI work to do. And then, yeah, probably some other things too that I'm not thinking of at the moment, but yeah, we'll get them in there. Cool. Yeah, so I think that's about all I've got in me for today. So I'll do some commits and pushes here. Cool. Yeah. All right. Well, I think that's all for my stream today. Maybe, yeah, maybe next time we'll work on some more stuff and yeah, have some more fun with it. So cool. Yeah. Thanks everyone for tuning in, and thanks again to Josh for having me on. So yeah, I'll catch you guys all later.